So, what do I have to talk about? I thought we'd make this very informal. I share some thoughts, some ideas I have about debugging, and maybe some experience I've learned working on software development, as well as working with students, helping students debug their code, debug their project. And you need to interrupt and you need to ask questions if you have any, or if something isn't clear. This is a topic where I think the main thing to convey is a set of experiences, and it's not less so saying, okay, this is this tool, there's these commands, use them, but more, what can you do with them? When would you use which? So I'm a bit uncertain of how I should convey that. So please work with me and be interactive. Again, I'd like to start out with apologizing for using Vista at the Linux. But I'd like to establish my Linux credentials here, if I may, for a second. This is my Linux counter page. You see, counter number 4 digits, 9524. Established January 1995. Does anybody know? Do I know what the Linux counter is?
I lost my number though.
Yeah, they send you a reminder. You have to, every so often they send you a reminder and you have to sign up. Anyway, so this was a fad when Linux became popular. Alright, so I'm using Vista for 2 reasons. For one, because it runs PowerPoint. And the second reason actually is that on this laptop, the Linux kernel freezes once in a while. Alright, so I called my talk Practical Debugging Tools. And I'd like to start out sharing an observation about bug finding attitudes. I said students' bug finding attitudes, maybe this applies to programmers in general. Okay, so on the x-axis you see years of programming experiences, and on the y-axis, I'll show you what's there. So there's first the tendency to assume that in debugging, that the fault would lie with some other part of the program. Okay, it must be somebody else's fault. Some instructor gave you some library or some tool, and this is where the problem surely must be. And with just program experiences, this tendency tends to decrease, although initially it is very high. This of course contrasts with the actual likelihood that the fault is yours, which that the fault isn't yours, okay, which for quite a bit of time remains in the door, and then with more experience goes up. So anyway, this is some observations I have. What would I like to talk about with you? Debug. Where does the term come from? It comes from, there's an interesting essay that hyperlinking here by Hayes in 1993, where in a journal article he talks about the history of debugging, points out that the
Can you open the door? There's somebody out there. Can we leave the door open too?
Yeah, it's kind of noisy.
Oh, okay.
We'll just wedge a...
It's going to get pretty hot in here, I think.
She's now about the history of debugging. But point out that the first stored program computer, the ADSAC computer in Britain in 1949, so when programmers first started programming computers, writing programs, that the second or third program, depending on whom you believe, contained the bug and took a fair amount of time, the bug took a fair amount of time to find. And so people realized early on that a large part of computer science is finding bugs in your programs. It's a well-known fact in software engineering that the earlier you find a bug, the cheaper it is to fix. Okay, so that's why all this emphasis on doing good requirements engineering, on coming up with good designs. If bugs, deficiencies cannot be caught, then your next level of defense would be to catch them when you actually code and when you compile your code, if you're using a compiled language, particularly if you're using statically typed language, or static analysis tools, and a number of tools that are now available, and although not many are open source, some commercial tools are available. And only if you can't find a bug then the next line of defense, the next point is to use a dynamic approach, unit tests, runtime assertions, or the consistency checking. And I would actually view dynamic analysis in a debug as a last resort. So only those bugs that have escaped in those parts of the design and development process need to be called by debug. So in this vein, let me start out at the, well, let's skip the requirements engineering and design phase. Let's say you already have some code and you want to make sure that it doesn't have bugs. So the first line of defense is your compilation process. And I cannot emphasize enough that the most important thing here at this point is to believe the compiler, to understand that the compiler is your friend. Crank up the warning levels at your compiler and heed the warnings that the compiler gives you. Here's an example of a student, the CL3204 student who didn't heed that warning. And if you look at the code on the left, this is a function void timer sleep. It takes in a 64-bit integer. I commented the actual code out of that function. This is the actual code. But so this is the what the function does in my world. And that's the main program, timer client. What is the question for you? What does this program do? So what happens if I compile this program? If I compile this program, timer client, timer T, no warning, you always compile with all warnings enabled. You get a warning that says implicit declaration of function timer sleep. Can you ignore the warning or not? Alright, okay, so a lot of students ignore this warning, implicit declaration, because they think, oh, it's just a warning, and besides, in C, we don't have to declare functions because the compiler declares them implicitly for us. But the problem is, when the compiler implicitly declares them, it assumes that the arguments to the functions can be represented as integer values. Here, timer sleep is called with 42, but if you run the program, you'll find that the function actually was called with this long 64-bit value. In this particular case, what happened was that the student then spent hours and hours debugging why their timer sleep function didn't work, when in fact the issue was rather simple. All they needed to do was to include timer.h on the use side, and they would have received the correct definition of that function, and it wouldn't have failed. People look either confused or bored. The problem is here with the 42. Okay, when the compiler compiles this unit. Okay, so it sees int main a call to timer sleep. It hasn't seen a declaration of timer sleep, so it doesn't know what is a timer sleep. What kind of arguments does it take? So it assumes that the arguments it takes will take an integer, a 32-bit integer, and so it takes this 42, turns it and passes 32 bits of that integer. Yet at the call side, sorry, not the call side, at the function itself expects a 64-bit argument. So the other 32 bits essentially filled with garbage. And so what arrives actually is this field. Okay, so lesson from that is you maximize the you turn on all warning levels that you can, -w all, at least, and possibly some others, and if there's a warning, you fix it. Another example.